Okay, let's see. Starting soon, it says. And he left. I got nobody. I need to work on it. I got a lot of things that I need to do. Very little time to do it. Hey, Kat, what are you doing? Oh, almost ready for streaming. Oops, Kat. Do I have a streamer back? Who showed up? Are you watching?
Yeah, I'm still logged on. Is the router running?
Yes.
It just says start.
All right, what are we doing today? I need to get this print working for a friend. Let's see if I can actually. And I've got to mess with this. I don't have a scene for Simplify 3D. 3D and source. And literally is not catching it. Oh, there it is. Haha. So yeah, there's simplified 3D. All right. So now I've got that going. What am I doing with Simplify 3D? So one of my really good friends is avid gamer, board gamer, card games. Very much into games. He actually has a game that you can either buy some game pieces for it, or you can make your own. And somebody on Thingiverse had actually put together game pieces for it. And it's a Star Trek theme. You can see there's Deep Space Nine, some Klingon stuff, and there's a Romulan, Cardassian, Ferengi, United Federation of Planets. And I need to fix this because it's not leveling very well. It's not capturing the settings window either. That's okay. You can't see it here, but I've got the settings window over top of Simplify. And I'm going to edit my scripts, and I've got a script that what the script does is essentially runs a leveling setup. I've got a smoothie board in this printer at the moment, and it's a smoothie board with a BL Touch sensor, and Smoothie does leveling different than Marlin and a little bit different than Repetier. And so I've got this script that is not showing up on screen here. It essentially runs through, clears the Z a little bit, deploys the BL Touch probe, and then goes through a probe, an actual probing in a manner that the smoothie board likes. And the way this thing works, it's actually got this offset, which unfortunately I think I really needed to adjust that. It's supposed to be about 2 millimeters for the offset, but it's coming up a little bit different now. It's about 2.3, 2.4 millimeters off, and I got to adjust this so that it knows the offset of the BL Touch. And to actually do that, I've got a script that runs through some of the bed probing and kind of sets it without the offset, and then I can go on my printer and actually go, there's the control panel that's on there. I can go through there and manually jog it down so I can get my offset that looks correctly, or that looks correct and actually is the correct height. So let's see. Let's get that light up there so I can see what I'm doing back there. You know, I really need to get a couple of really cheap USB cameras. Just throw another cam on there. Watch out, kitty cat. You want me back here. Come on. Come on. Good. Fuzzball. So yeah, there's that. And I need to run a test. And this printer that I've got set up here, I've actually got Octoprint. There's an Octoprint little Octopi right here set up, and it's got a camera directly on the board, or directly on the print surface. And that's good for recording the time lapses and everything, but I really need to get an actual camera on there for streaming. So let's see. But I need to fix the offset first. So I'm going to log into my Octoprint server here real quick. Shut that off real quick. So, all right. All right, let's see. You know what? While I'm doing that, I'm gonna go ahead and start the bed warming up to 87C. I usually print like PETG with an 87C bed. It just seems to be a really good adhesion temperature without going too hot. And I've got a bed level offset little G-code file loaded on the Octoprint. And I just usually run that and kind of get a good offset, or get a good start for the offset checking. Got some of that dangling filament in there. And let's see. I could actually probably move that camera. That might not be a bad idea. I'll do that later. Let's get this damn thing printing first. Okay. That level offset, go ahead and run that. Okay, so now that's run through. I'm going to go ahead and actually go on to the terminal that's in Octoprint and shut off the temperature messages because I don't need to see those. And I'll do a G1 Z0, which is moved to Z0. 5 and G1 Z0, which is pretty damn high, actually. That's probably why these prints aren't sticking. So, we're over here and manually jog this down. Down 2 millimeters, and that's crazy. All 3. And we'll go back to 2, and then we'll do 0.1. And I will use a sheet of paper. Gap that. Looks like 2.4 millimeter, actually 2.4 millimeter. Back out of that, and then we'll fix my offset. And I will also yank this camera out and move it around. Let's see how well this works out. Knocking everything over, making a mess. Get all this wiring out of the way. It wasn't the best way to go with that wire. And of course my workbench here is a whole lot thinner top on it than the desktop. All right. One of the stiffest things ever. Yeah, let's see if we can fire that up, see what that shows. All right. We'll go click you back on. Hey, that looks pretty good, actually. So I'll leave that one on. And wrong window. Let's go back over to simplify. And I'm gonna just fix my offset here to 2.4. And yes, I am setting my offset in my scripts, which means my G-code scripts are not reusable if something ever happens to my offset, which is a problem I'm aware of, but for this setup, it doesn't bother me that much. I don't really change it that often. Okay, so 2.4, yes, okay. Let's reslice that. See what we got. I'd like to go through and actually take a look at how it's going to adhere. And of course my heated bed should be nice and toasty. So that's good. I'm going to go ahead and save these to Starbase. Yes. I got that saved. I am going to upload that over my Octoprint. And now that that's uploaded, get it loaded to print. Temperature is, the bed's at 87, so we'll go ahead and start printing, and it will start. You'll see that there, it'll actually start warming up the head. That'll happen pretty quick. And then hopefully this thing starts laying down some good solid first layers and starts printing, because I'd really like to print these parts for my friend. He was going to put them together and actually paint them. Hopefully that works out. Well, that's warming up my other project here. Right up here behind the lamp is actually my giant 300 by 300 by 500 plus Hypercube Evo, which it's got all the motor wires dangling at the moment. I still need to extend those and run those around, and I got to figure out where I'm going to put the control board so I know how long the wires I need to make. And quite honestly, I kind of want to put a plate across the bottom of it, mount everything on top of the plate. There's plenty of room in there. The bed doesn't come down that far. There's actually a substantial space underneath that I built into it. Like the verticals are 800 millimeter. So there's 800, or there's 100 on top for the mechanics, the XY print mechanics. There's 550 for the bed, and then there's like another 150 plus for the base underneath. I just need a base. I need a platform. Need a lot of things. All right, that's moving. And let me go watch it go through. Exit startup. Grab the filament off the nozzle there. Is it printing? Is it going to print this time? That doesn't look too bad, I guess. I'm just taking its sweet time starting the filament. I don't have a priming strip that I do to prime the filament, so when it starts printing, it usually doesn't have anything flowing. Hopefully this just starts working. I tried to print this earlier and had some serious issues with it adhering, but that was a whole lot cleaner than it did earlier today. So much better. And I think I'm printing these out at 150 micron layers. Micron, is that the right term? Is that what I set it to? Yep, they are at 150.15 millimeter layers. They should come out some decent quality. Gosh, that That little webcam I have is pretty, it's pretty rough. Don't screw around, just print out normally. There's a couple of gaps in that object in the back that it put in. I'm not quite sure what's going on with those. Oh, and there's the loss of adhesion. Flat out. Why is that? I just put fresh hairspray down on there too, so it's actually got a pretty good sheen on it from that. Maybe it'll survive. Let's see. Let's see if I can assist it. I don't want crappy parts for my friends, so these are only test prints. The actual full batch for all these parts would actually take up the entire bed. I think part of the problem with that, how it's pulling up is, I think the nozzle's a bit dirty. It's got some PETG caked on and around it, even though I tried to pull one of it off. So I think some of that is actually contributing to catching some of the filament that's already been laid down. You see a little piece of it there. There's more on the print head. That's interesting. Hopefully this stuff works out. We'll see how much of it actually survives. Let that run for a little while. Let's see. I have one viewer. Alright, now let's try. I'm gonna take a look at some options for cameras. I'm gonna go on Amazon. Just like some basic web cameras for just dropping in on my printers. Nothing super. Shorter moves are sticking to the head a little bit easier than the longer moves. I hope this works out and it starts filling that stuff in better. Alright, you stay stuck to the bed, please. I need my crimpers. I'm going to do some test crimps here, actually. My crimpers and my cutters. And we'll go with some yellow. I bought a bunch of silicone wire and multicolor that actually matches the colors of the lines on my steppers. So I can definitely go ahead and extend those and actually keep it looking nice, keep it consistent looking. Alright, you crazy printer. And the Duet kits here actually come with a really nice set of plugs and all the metal inserts. You can actually, the crimp-on inserts for making all these plugs. And I do have a crimper, actually. I picked up this crimper a while back for smaller work. I have a much larger one that I use for things like my Anderson power poles, which are much higher amperage connectors. I just want to test these and make sure I can crimp them correctly and get the right process down. And where did my wire? And there are my wire strippers. And get those suckers set for as small as possible. Which actually turns out that's pretty good. Well, it's stripping quite a bit long. These strippers are intended for larger wires. So I'll just fold that over. Let's see which die these fit. The bag will say these are it does not say. It looks like it would fit in the 5.5 millimeter. Does look about right. Grab that, insert, just squeeze. And make sure the damn thing can come out. So there that goes. And all the connectors would get 3 or 4 of those crimped on. And thankfully it does look like it. Actually, it looks like it only crimped half. There, that's a full crimp. And for one like that, it would fit in after it's crimped. Just like that. And this wire is not stiff enough. I would probably need to poke that in with a needle. Yeah, there we go. So yeah. We got one wire in there. That seems to be all right. And we'll get that stripped down a little short. It just doesn't want to fit in that one. And crimp the other end of that one and see what comes out. Not quite as it's like the die in this crimper is not it's not exactly set for these types of terminals, so I got to double crimp them twice. Okay, that with that, push it down till it clicks, and sure enough, there's a connector. And I'll probably use that some other time, so I'll just split it and have a 2 connector or 2 wire connector. Or that might be an end stop later. All right. So now that I understand how the crimping is going to go, let's check this printer. Looks like there's one part on there that's just a little dangly. Let's see if I can use my knife and cut that dangly part off before it catches anything else. And honestly, I'm at the point with that printer where I just really need to rebuild everything on it. And I might. So while that's going, I will be right back. I need to find my LEDs. Where did I put those? I found my LEDs. These are, it's a strand of 12 volt white. And I was actually going to set that up on the inside of the printer. Actually, the box that I put together for it. Hopefully, get that darn thing illuminated. And I think I'm going to run it across the top on the inside, down half of this front pillar, since the camera's right below it, and it can illuminate straight towards the printer, and then along the top over here, it should actually light up the entire case pretty well. These 12 volt LEDs are pretty substantial. In fact, let's see. That one. Oh, because the whole thing is off. Yeah, I should probably crank that back on. So, as you can see, these things are exceptionally bright. Really great for lighting up a workspace. It's got a couple of clamps at the end too. And it's flexible, which is nice. But the LEDs I have are just like that. Actually, this is from the same spool. So I wire them up just like that. This little 12 volt power adapter. The printer itself is 24 volts, and I don't have a 12 volt source in it. So I can't run the LEDs from the printer or any of the printer supplies without like a 24 volt to 12 volt regulator. One of those I don't have set up at the moment. So let me see. Let me see about get some of the rest of this out of my way. And wiring up the strip. I gotta measure these out. So I can cut that one there, which is nice and easy. And where did my other box of LED stuff go? Got a bunch of RGB LEDs that they have for various other projects and connectors for them, which I've got these barrel jacks. Should fit. Yep, they fit. So get those barrel jacks. And I need my soldering iron is what I need. Time to take out the soldering station. This would be the Hakko FX888D digital. Go ahead, drop that in there. Let me get this set up right here on my desk. Grab some solder and get that thing heated right up. It's going to take this strip, and actually this is going to be the first strip. So I'm going to put the power connector on it. Clip off some of this insulation. They're claimed to be waterproof, and they've really just got a bubble of clear silicone over the top of them. Not super waterproof, but I suppose in most cases it's resistant enough. What am I printing now? I'm actually printing some game pieces that are Star Trek themed for Jared, guy I work with. And Jared was looking to get some things printed out. Get those tinned up. the wires here. Those are probably in desperate need of flux. And even better now, I forgot. Hey, Germanice, you're back. Welcome back. Yes, it's the workspace. It's the workspace with the printers and everything, and now I got the printer going. Printing out some tabletop board game pieces for a Star Trek themed game a friend of mine has going, and he wanted to get some samples printed up. So I've got those going, and I'm also working on the thing above my head, which the first one here is an LED matrix that's not on at the moment. The second one is a PDP-8 front panel replica, and the third one here with the red LEDs is a PDP-11 front panel replica that is currently running the RSX-11M operating system. It's a full-on, it's emulating an old mainframe from the 70s and 80s. Actually, I think they ran PDP-11s all the way up through the 90s, and there's probably still a few somewhere in use. But the front panel, actually, the front panel display on it always had this really cool LED effect going. It's got switches on the front of it that you can actually completely control the entire machine. You can actually you can inspect and enter data with these switches on there and control the whole thing. Same with the PDP-8. This is an older one. It's currently not running any program, so it's just kind of sitting there flashing and looking happy. And the first one here is it's just a Raspberry Pi with a 32 by 32 LED matrix that I don't have plugged in at the moment. The PDP-8 and the PDP-11 were kits that I purchased from a guy who put them together. I recently did actually a build stream of that one. Unfortunately, Twitch deleted it before I got to archive it. They dropped the archive, or they dropped the hold down to like 14 days, and I missed it by a couple of days to archive them. And I made this one I put this one together about 2 years ago, the PDP-8. Those are the front panels. No, it's not a lull spot. It's actually the machine that's printing now on the big camera is a Mendel Max 3 from Maker's Toolworks. It's a highly customized, bastardized Mendel Max 3. And if I have some extra money, maybe in the next month or two, I might buy the upgrade kit for it. They have an upgrade kit that replaces all of the V-slot with actual linear bearings, decreases the mass on that X carriage. That X carriage is huge, and it's stable. It is fantastic, but it weighs a ton. So there's that. But that kit's like a $400 kit, so that's not going to be anytime soon. And then to the left of it, over here, I've actually got my Hypercube Evo, my giant monster. Let's see if I can. Yeah, there we go. The Hypercube Evo. It's a 300 by 300 by 550. Yep, printing directly on glass. Yeah, the other machine is huge, and that's the one I'm currently working on building. It's still got a ways to go. This is PETG filament that I'm printing on the Mendel Max. and that's printing on borosilicate glass with hairspray, Aquanet. It's actually, this stuff holds really effing well. A little too well sometimes. So the print looks like it's doing pretty well. Yeah, there's a funny thing about ABS. You're saying your printer only likes ABS. One thing I noticed is that when you start printing ABS through a hot end, the ABS leaves a residue on the inside of like the heat break and the nozzle. And that ABS residue, ABS will flow right by it, but other things like PLA will tend to stick to it. And it's really hard to clean out. It's like I printed ABS for quite a long time, and when I tried printing PLA, like it was 100% perfect with ABS and PETG. I put some PLA in there, and the first thing that happened is it stuck. And I replaced the heat break, and PLA went right through it. ABS went right through it. PETG went right through it. But if I put more ABS through it, it's going to go ahead and it's going to leave some of that residue on there. This ABS, it's a great material, but it's a bitch to work with. All of the fumes, the outgassing, the residue it leaves. So yeah, I need, right before you came in, I was gonna grab my, where did it go? I have a heat shrink tubing, so I can actually insulate this wire. What I'm doing at the moment is I've got these white 12 volt LEDs. Slide that back down. I have these white 12 volt LED strips that I'm going to put inside the case where the Mendelmax is to actually illuminate it in there a little bit better. It's not very bright in there at the moment. It's, you know, surprising. The camera's actually adjusted really well to it. But I wanted to get some of these together and at least start getting some light in there. All right. Yeah, apparently it looks like I am running low on 330 seconds. I have to order some more of those. Go ahead and slide those over the ends. And I will get the Adafruit LED plates. Those are the really big ones, right? Like the 2-foot plates? Or are you talking about like the smaller ones? And I just dropped it. Clumsy, the smaller ones. Yeah, I don't need a huge amount of light in there. I just need enough to make it a little bit easier on the cameras. The cameras aren't the best in low light. They're just little cheapo cameras. These suckers stuck together. Get some solder over here. Come on, wires. So yeah, just trying to get these power wires together for this, at least something temporary. heat shrink slid over. Actually, I want to redo this one. Taking my second Nintendo Switch apart for mod chip right now. I got a Switch for my birthday back in July from my wife, which was really nice. And I have seen a lot of the mod stuff on it, or on that people are doing with the Switch anyways. But I really don't want to screw with the new one that I have. In fact, for 3DSs, I actually have my primary 3DS, which is unmodified, and my secondary 3DS, which has all sorts of custom stuff on it. And where's my lighter? I need a lighter to shrink this tubing. And when I say lighter, I mean like full-on butane crack torch. That shit works. Yeah. Yeah, crack torch. It's funny. It's something I picked up from somebody I used to know. Alright, so hopefully this doesn't blow up. And this just lights up correctly the first time. Yeah, there we go. That giant hula hoop actually is one of these. It's literally a hula hoop cut open, and it's got an entire strip mounted to it, and it's got little clamps on the end, so you can actually clamp it onto a table, and it provides a full-on arc of light. Yeah, here, let me. It is one of the coolest portable, like, work table lights ever. There's just clamps on the end of it. I was actually streaming with this a couple weeks ago. Actually, when you started following me, I had this over the top, although you couldn't see it because it was out of frame, and it was lighting up my work desk. It's awesome, and it's really nice because it's kind of this full-on 180 degrees of light. Yeah, drone racing. Yeah, you could definitely do that too, but then you'd have to run 12-volt power out to all of them. Do that out in the field where somebody's doing this. People are going to get real sick of running extension cords. Although I suppose you could put batteries on them. A 3-cell, yeah, actually 3S would power this really well for a while. In fact, I have some 3S cells up top. You can see where my finger's pointing. You can actually see that's the motor and propeller for one of the quads that I have. It's stuck in the back. I do quads too. I do all sorts of radio control. Although you can't see a lot of it. There's a really large radio control plane off to the side. This is my 6-foot wingspan, all-electric P-51. Close to a Spitfire, P-51. And this is a 100-mile-an-hour plane. This balsa batteries, this thing hauls ass. And I absolutely love that plane. And I've actually flown in a real one. Set that aside for now. Unfortunately, with my workspace being rearranged, that plane actually used to be in the corner where the printer is. Of course, now the printer's there, so I got to find a new place for the plane, which will probably be in my other room. I've got that plane. I've got a T-28 that is also electric. Actually, all my planes are electric. I think I have about 8 or 9 planes currently. 8 or 9 planes, a couple little teeny tiny quads, and then one 450 millimeter quad up there. I don't have any racing quads. I just don't have the money to spend on them because I spend all my money on this crap. Oh, what's going on there? Let's take a look at that. The smaller round object on the right looks like it's actually grabbing some extra filament. It might have actually pulled some off of the print head. Oh yeah, look at that. Some extra PETG. In fact, there's quite a bit stuck on the print head at the moment. I think I really need to swap out that nozzle. Yeah, it is a bit like cleaning your wax out of something. Yeah, unfortunately, some of those printed parts aren't coming out terribly well. That's okay though. This is a test print anyways. Hopefully some of it comes out and I can show my friend that I'm printing it out for tomorrow. Oh man. Excuse me. Also, since it's Halloween, I have my one and only Halloween decoration up right here behind me. They are the flame flickering light bulbs, and they're little bird cages with crows in them. So, yay, Halloween. My wife, on the other end, has like 2 whole boxes worth of stuff over there that's going up, and we have candles, and we have all sorts of stuff. Your racing quads fit in your hand? Yeah, are you doing like little 180s, 200s? Actually, I thought about picking up a smaller one to mess with, but yeah, 120 to 180, oh, really small. Gosh, yeah, GT90. I think I've seen one of those. I follow Joshua Bardwell on YouTube and follow his videos for all the quad stuff. And they do a lot of racing. He's more focused on racing. I have a lot of friends that have actually larger drones as well. And of course I've got the 450 that's up there. I just haven't really had the extra time and the money to get into it. And now that winter's coming, flying outside is going to be like few and far between. Oh, why are you making funny noises? Use goggles and sit by the door entrance. Yeah, I could use some better goggles too. I have some pretty old fat sharks, and you know they're all right. They're just not super goggles. They're just some decent. Gosh, I think back when I bought them, they were like $300 and some odd. Put all of those. Yeah, actually I got some of the stuff stuck in a box back there. Still organizing all this junk that I now have in my workspace. And it's honestly like when I go out flying, I usually go out to there's a park not too far from here that's it's huge. It's 60 acres worth of grass, and there's so much space out there. I can actually fly my larger planes out there. There's so much space. Oh gosh, let me take a look at that. Yeah, there's just like little PETG boogers all over the place. So I did the 120 so I could fly after work in the warehouse. Yeah, that would be pretty good. I work in an office, unfortunately, and it's not, well, I mean, technically it is large enough for a 120, but everybody else in the office would be dying. And the area my office is in too is really nice. It's actually right next to a lake. Well, unfortunately, my office is on the other side, so it faces the freeway and not the lake. Yeah, if I like, honestly, I'd like to get a new Mavic Pro too, and take that out. I could actually fly it off the balcony over there. Technically, I am in the office, but I have the keys. You're actually in the office now? It's like your own, like it's your business, or you're like a manager. Manager, okay. Yeah, I am just a lowly, I'm a tier 3 support engineer for Microsoft. Doing last minute things for trade show next week. Ooh, which trade show? What industry are you in? More of a mess. Wastewater filtration. Huh. Turn that piss right back into drinking water. Let's see if I can click that little nub off this. Normally I wouldn't do this for a print. Normally my prints don't actually string and ooze that much. You guys do like the particulate filtration, not the actual like reclamation for drinking? Doing it for flushing and irrigation. Oh, okay. So yeah, I can actually, I'll bring up Simplified 3D over here, and hopefully you can actually see that correctly. The only team that was able to design something close to drinking is the web team. The web team? Like the website team? Yeah, so these are the game pieces that I'm printing. They pack more design power than the engineering team. That's kind of sad. So yeah, there's a base plate here that's generic to all the pieces, and I'll probably print out like 16 of those. And this is almost a full set of parts for various space stations that act as game pieces. Yeah, it's a board game. A friend of mine has a board game that he's playing, and he wanted to actually have some real pieces for it. And it's Star Trek themed. Like this one that's selected here is a Cardassian space station, like Deep Space Nine. And there's that will flip over. It's like a Federation station. It's not quite like Warhammer. It's more smaller session versus large wargaming. I think a complete set of these is only like 15 or 16 pieces. So it's not super huge. In fact, if I get all these printed out for him and he gets them painted, he actually might bring those pieces to game night, and we might actually play. We do game night with a bunch of friends every couple of weeks. All right, so let's see. Of course, I can't mount this LED strip while the printer's going. And come to think of it, the adhesive that usually comes on the back of these is shit. So I will very likely maybe 3D print some clips with little screw holes on them and just kind of like put the clips up on it, screw it down. But at the same time, I still need to cut out and measure additional pieces. Go ahead and cut that one there. And then I will measure out another one that goes along the top, just like the first one. So do the same length. And cut that sucker off right there. All right. Let's get a bird's eye view of how that's actually printing. It looks pretty horrible. It looks really horrible. But hey, I will let it finish. I will let it do its thing. I've got some wire here, some spools. Let's see. Probably do a short connector there. And then, unfortunately, have to run the long one back up. So this wire connector will likely be the length of do these work in parallel like that? I don't know. That's a good question. Let's find out. Okay. Been playing with RC Drifters 110 There's actually a drift track, an indoor drift track, not too far from me, and it was kind of surprising to see because I haven't seen an indoor racing track in a long time. You know, it was something that you used to see in the 80s and started falling apart in the 90s. And then, of course, now that you've got LiPo that's pretty much brought back RC racing. There used to be a really nice outdoor track at the hobby shop that I used to frequent when I lived in LA a couple years ago. Really, really nice track. All tracks closed up here in Houston. The last remaining track's the indoor drift. Yeah, I haven't seen any other RC tracks up here, although I haven't really been looking. I haven't really been looking for RC tracks specifically. But in fact, actually related to game night, when I head out to game night where my friends are, the place we usually game at is right up the block from the RC Drift track. Hey, Wally 1970 Tanker, welcome to my stream. My name is Duo. I do all sorts of electronics, 3D printing. Right now I've got 3D print going with some game pieces for a friend, and I'm also working on some LED lighting strips for that to light up the inside of the container that it's in, the box that I've got going. I also do some gaming here and there, and just lots of little electronics projects, 3D printing stuff, design. If you have any questions, let me know. So yeah, let's see if I can get this strip soldered together. Get these wires stripped. And we'll start getting these lighting strips. Looking into a 3D printer, but more about metal fabrication and its application in 3D printing field. There are metal 3D printers. The downside is the printers that can do metal are expensive. There's a lot of energy that's required for metal printing, either if you're doing sintering or if you're doing, like literally direct melt printing like we would do with a plastic printer. There are a lot of machines that will do metal, not really on the consumer end though. Although if you do want to have actual 3D printed parts made for you that are metal, there are services. There's one really popular service, Shapeways I think it is, that will actually make, you feed it models and it will send you back metal parts in various materials. And of course, depending on how much metal goes into it is how much it'll cost. Quite honestly, for any of the consumer level stuff, if you're not willing to spend $20,000 or $30,000, you're going to be working with plastics or resins, laser-based resins. Those actually work pretty well. The printer that I have here, actually, that's on camera, that's printing right now, is a Mendel Max 3. Prints most plastics really damn well. It's currently printing in PETG, which is an extremely, extremely hard thermoplastic. Really good stuff, really high temperature resistance as far as plastics go. Super rigid parts. In fact, the black frame here, all these pieces that are on this printer, which I'm currently building, are also PETG. And I do have some ABS here as well. Get that on there. The ABS printing I have done in the past has been pretty strong. These parts are super durable. It's PETG, P-E-T-G. Actually, you can see up top, there's a box here, it's P-E-T-G. Well, I'm looking into building it myself and making its space worthy for mining materials from asteroids and refining the metal for use in a printer in zero gravity in orbit. That's an interesting idea. That's way beyond what I would use. Does it smell? The PETG actually doesn't really smell at all. PETG is pretty damn fantastic for that. It's not quite as nice as PLA. PLA like almost has a pleasant smell to it, and of course ABS smells absolutely horrible. What's the melting point on PETG? This particular one, I believe, has a minimum temperature of a minimum printing temperature of around 190. As far as the stability on the final parts, you can anneal them in an oven for a little while, which shrinks them just a tiny little bit, and they're good usually up to 120, 130 C. I don't use them in anything that directly touches stuff over 120. In fact, if you look at the printer on camera here, there are these white clips in the corner. These clips are the bed clips. It's a later modification for these printers that the manufacturer supplied. This is white PETG, and they're directly holding the glass on the bed. It's been through hundreds of hours at 100 C, and they haven't deformed in the slightest. Just theory right now. On paper looks promising, but need to start somewhere, and the stream was up and running. Well, thanks for stopping by. Yeah, I really appreciate that. Wally, one of the things you might want to take a look at too is SpaceX actually does use 3D printed metals in their rocket. Actually, I'm not sure if they're using them in the rockets themselves at the moment, but I know that the Dragon capsule actually has some of the escape rockets on the Dragon capsule have 3D printed combustion chambers, and they actually 3D print those in Inconel, which is amazing. It's one of the hardest alloys known, and they 3D print with the stuff, but of course it uses a whole lot of energy to be able to get that stuff melted. And it actually end up not changing the alloy in such a way that when you actually have a final part that it's actually weaker than other types of Inconel parts. Yeah, Germany's like PETG. PETG is really awesome. The parts, I mean, they are rock hard. They're harder than ABS. ABS has a little bit of flex to it, even though it is pretty strong. I'm not sure on the actual overall strength versus ABS. I think they're pretty close, but maybe PETG is a little bit stronger. But it doesn't give. With an ABS printed part, you can cut into it with screws if you actually want to drill out screws. It will take threads from a screw really well. The PETG doesn't really take thread very well unless you have a really good cutting screw, which is why a lot of people actually use things like brass inserts in PETG. You actually take a brass insert, stick it on the end of a soldering iron, heat it up, and then you can literally stick it right into the plastic and it will stick, and of course then you'll have a threaded brass insert. Yeah, it takes forever too. Yes, it does take forever. Got family over there in Houston, NASA, and SpaceX. Yep, I know people. Actually, I know a guy who used to do composites for SpaceX. He actually did composites for the fairings that they use, and he moved on to another job. And one of my friends actually right now, one of my really good friends is an engineer they're in school to be an engineer, and they're over at SpaceX all the time in California, just like learning and checking things out. So yeah, SpaceX is some pretty awesome stuff. Let's get a checkup on that nozzle, and it does look like it is printing okay now. I'll definitely I'm gonna have to do some more recalibration on that printer. The printer's long overdue for maintenance. I don't think I've done maintenance on it in like a year and a half. And of course, if I do maintenance on it, I'm going to want to buy the upgrade kit that converts everything to linear rails. And I'm going to want to spend money on that, pull the whole thing apart, put it all back together, probably throw a newer controller into it. The controller that's in it now is one of the knockoff Smoothie boards, and it's so neglective. Actually, that machine is rock solid. The few times that I've had to do maintenance on it, immediately after the maintenance is done, the machine just runs. You just flip a switch, load up a file, and it goes. Every 5 or 6 prints, I'll go ahead and actually clean off the bed, clean all the hairspray off of it, get it completely wiped down clean, and then I'll put like 2 or 3 coats of hairspray on it. Let that bake off at like 80°C, so it gets a really nice bake to it, and it sticks. Like, parts will stick through multiple prints. Yeah, that's why they kept the 3D printer that does ABS as ABS only. Yes, if you're gonna do ABS, either dedicate that machine directly to ABS or get really friendly with pulling the print head off and changing out that heat break. Because that heat break, ABS will kill it. I mean, and the ABS will flow right by it, which is funny. It's just any other material that goes into it just dies. In fact, up top, right next to the box of PEG, I've got a bag that's PLA. It's Atomic Filaments Starry Night PLA. It's a dark blue purple. Really, really, really beautiful color. In fact, this is a print I did on it as a test print. And it's got this, the camera doesn't even really do it justice. It is a little bit more purple than blue. And it printed out really well until the jam right at the end, which was from the ABS residue. Like, I did everything I could to get this print to go. My group is wanting to build a rover to mine asteroids and use materials to build other things in space. That is a really cool idea, and we will definitely get to that point. 3D printing would be the backbone of the industry for sure. Yes, that is absolutely one thing you're going to definitely need out there. Either you're going to have to find a way to get parts up to those machines really easily, really quickly, make them indestructible, or make 3D printing for parts and maintenance and expansion. I mean, once we can actually get a 3D printing technology that you can feed it raw material and or at least cook down ores and get nice parts out of it, or even, you know, some basic stuff. 3D printing is one really neat part of a process that would be involved in that. You would have, you know, printing, you would also have milling. There are printers and mills, printer and mill combinations that can actually print the material and then finish it with detail and do, you know, mill out actual threads for screws and things. You know, that there's so much coming for that. Unfortunately for me, I think it's going to be pretty far off, but we're getting there. This is the beginning of all of that. All right. Oh, yeah, I should finish my beer. There is a video of a 3D printer using cement to build a house. Yes, there are actually quite a few cement printers. There was a guy a few years back that made a small one. It's actually a Cartesian printer. The base idea is exactly like this. You know, there's rails and the moving print head. And he built one that actually printed a concrete playhouse for his daughter in their backyard. And a couple of other people came up with some other ideas for an actual, like a rotational printer. What do they call that? It's a printer type where the actual print head is anchored in the center, and the print head can move around in a circle. And they printed houses with those. They printed houses with giant Cartesians. They have, gosh, they printed so many things. Concrete is surprisingly cool. Munich University got one that builds bridges. Yes, carbon fiber printing is a thing. Wally, actually, I will show you here. Atomic filament. If you can see it on the camera there, this is carbon fiber black PETG. I haven't cut into this yet, and I know this material is fantastic. I got to play with it at the Midwest RepRap Festival earlier in the year. There is, like, that's an actual PETG plastic with carbon fiber actually milled in with it. So the strands are pretty short, but the parts that come out are extremely strong. There is also there is a printer that's kind of a specialized printer that will take regular plastics. Yep, there's wood fiber too, and I have some wood fiber as well. But there's a printer that, I forget what the name of it is. It will take a spool of plastic, and it also will take a spool of actual carbon fiber thread. And while it's printing the plastic, it also lays down carbon fiber thread along with the plastic. So you have carbon fiber wound throughout the entire printer, or through the entire print. And they do come out pretty strong, but there are limitations to it. Yeah, quite honestly, like this carbon fiber PETG, this stuff is fantastic. The only downside to carbon fiber printing is that carbon fiber is extremely abrasive, super abrasive. It will blow out a nozzle within, gosh, I think they were anywhere between 50 and 100 hours worth of printing. The carbon fiber will blow out the nozzle, so the nozzle diameter is actually larger and completely uneven. So you definitely need to, you either buy special hardened nozzles, which cost more. There is a Ruby nozzle, Olson Ruby. A couple of other companies make Ruby nozzles. Markforged, yeah, Markforged, that's right. Also, this nozzle that I have here in my hand on the camera, that is a brass nozzle coated with a hardening material on the outside to resist wear. This is a prototype from E3D. They gave these out earlier this year at MRF to let people play with them and see, you know, just how long they would last. I haven't actually mounted it on anything yet. I haven't opened up my PETG yet, my carbon fiber PETG. So arc welding wire fed into flux with carbon fiber to set up structure. Yeah, actually, Wally, there is a printer setup that they have that's based on a full-on servo arm, you know, with full control, and it's got a print head that will use an actual arc welding wire and all the material to build up metal objects. The resolution isn't super fantastic on it because, I mean, it's when you're arc welding, it's not the finest process. But they built a bridge. Germany was saying earlier, it's like literally they had these machines build a metal bridge and connected it, and it was a functional structure. You could walk on it. In the process of getting a Markforged in the office, but no funding till next year. Yeah. The previous office I worked at was a manufacturing facility, and they did a lot of furniture and bath fixtures and things like that. And while I was there, actually, I got to be really good friends with one of the designers. And he started talking about 3D printers, and he said, "Hey, I'm thinking about looking into 3D printers. Do you know anything about them?" And I knew a little bit about them. And he actually got the company to buy a Robo R1. And the Robo R1 is an okay printer if you're just starting out and learning, but it's not a durable machine. It's not a printer with longevity. But I helped him and the entire design department actually learn 3D printing and work around that, which was great because they were already using high-end CAD software to design all this stuff that would get made out on the manufacturing floor. And then they started making plastic fixtures to help with the production out on the floor. And that was really cool. And to be part of that process was awesome. But unfortunately now I'm working with Microsoft, and we don't do any 3D printing stuff. The stuff I'm working with Exchange. You would only need a variance of a few millimeters to make anything work correctly. Yeah, a few millimeters is definitely fine for larger structures. And on the scale of things, like the resolution of these machines, the best resolution in the Z-axis I can get on this machine is about 75 micron. X and Y is maybe about 75 to 100 micron. Of course, you scale those parts up to something much larger with a larger printer. You're going to get larger parts, but of course your tolerances are going to go up as well. But even a few millimeters on a super large structure is not a huge amount. We'll have to get our team a $1,500 model to get used with. Yes, 3D printing. If you're going to be working with larger stuff in the future, you definitely want to start off with a smaller printer and a reliable printer, something that's actually designed really well and put together, that you can actually either you get the kit and put it together and it just works, or you buy it completely assembled and it just works, so that you can understand the flow of going from something like some of the CAD software to the slicing and breaking up those designs to be able to print them and get used to the whole workflow on that. It's definitely really good experience that any team that's going to be manufacturing parts, that's going to be designing new types of machinery, new types of vehicles, things like that. 3D printing is fantastic. Like you really need to get into that and understand the process and work with it. It's accelerated. Manufacturing, car manufacturers use 3D printing all the time now, either to throw together prototypes, or there's a couple car manufacturers that will actually give you add-on parts for your car, like little accents that are all 3D printed. It's really, really interesting. You know, you can put out a brand new part really quick. Yeah, work, I'll have to decide on that in 6 months. Stick with the noob company and introduce them to new tech, or join my old company at the new location and be on the bleeding edge. Honestly, go with whatever pays better. My advice for that is definitely go for that paycheck. All right, so actually, I got distracted here and I got these wires that I am going to solder up for this LED string that I'm going to put in the case. And of course, I don't have any of my jigs with me. Put some solder on these wires here real quick. Speaking of using metal, and I don't know if I said this earlier, Wally, I'm putting together some LEDs to go into that case that's got the printer, just to give it a little bit better view on the inside, because the cameras are not super strong in low light. just some 12-volt white LEDs. Okay. Zach, don't inhale, dude. Out the window. We are working on a Jeep frame, set it up as a rover for the mining part with a used CNC drill that works so far in the shop. That's pretty cool. I have seen people do lots of cool things with Jeeps. They are easy to work on. So I hear. I don't actually know that for sure. Okay, let's see. Clarity. Get some solder over here. Of course, on my desk here, I've actually got this silicone work mat. No, actually, this is the Hakko FX888D. It's their, I think it's 140, 150 bucks around there. It's digital control. The wands are fantastic. The tips that Hakko makes are they're so great. They have great longevity. And they make some really fine tips too if you're doing fine tipped SMD work. Although the basic tip I've used for everything I've done, and it works really well. This mat's just a silicone mat, and it stands up to this soldering iron really well. Get that attached, and get this attached also. But again, 3D printing would make it so much easier, I think, for building the parts of a sophisticated machine. Yeah, no, like 3D printing is, the technology is still pretty young, at least for the hobbyist side. The professional side, the technology is just growing by leaps and bounds. So 3D printing is definitely a huge portion of the future for any manufacturing, especially projects like that where you need to build something on site, or you need to have special implementation. Bright LEDs, exactly as they should be. Of course, it blows out the camera that these things aren't so bright that I can't actually look at them. Not quite as bright as they look on camera. So I got that section of the strip put up, and now I'm going to see if these strips are wired in such a way to let me run them in the second one in parallel. Sunglasses indoor. We're using an older CNC machine to mill our own parts out of billet metal. Takes forever, and the drill heads are expensive. Yes. That was one thing I definitely learned at the last job that I was at. Those drill heads are phenomenally expensive. And most of what the company I was working for was, the materials were mostly wood or MDF materials. So yeah, just, even though the wood cutting drill heads were super expensive, and the metal ones are just way beyond that. Let's get these wires stripped. Alright, wires are stripped. These are nice silicone wires too, silicone coated wires. They are super flexible. So when I actually get it stuck in the case, I can bend them around corners really easily without having to worry about them. Alright, let's get these ends tinned up. These wires tinned. Also, too, oh yeah, we broke 4 in 1 week. Oh yeah, yeah. When I was working at that company, I didn't have to actually pay for the damn things. It wasn't my department because I was technically IT. But wow, whenever we had that guy come in from the company to bring us replacements, boy, everybody hated that day. So much money went out the door. All right, let's see if I can double tap these in. No, of course not. All right. Essentially just getting a splitter soldered in here. I believe these strips run okay. Ouch. In this manner. Not 100% sure. We'll see. This thing about silicone wire, the silicone coating can definitely get a whole lot hotter than you can hold before it even starts to melt. Casting is another thing we thought about, but the furnace for that is also not cost effective. Yeah, and in fact, investment casting, there are people that are using 3D printing for investment casting. Literally 3D printing up the model and in plastic and building a cast around that, and then of course, like Lost Wax casting, burning the plastic right out of it. Yeah, and then you have the EPA burning down your neck about emissions. Exactly. All right, let me get this other strip wired up here. We are 12 volt at the top, other direction. I gotta cut the insulation off. These LED strips have a little bit of clear silicone right over the top of them for some basic waterproofing. Not that it's super effective. And we'll tin those ends up as well. So Wally, where are you guys based out of? You have a website with your team that's doing this kind of work, these projects? You can go ahead and post a link in chat, it's okay. Hey, all right, Johnny's. See you later. I might be on a little bit later, might not. Check back. Good seeing you, man. Nebraska. All backyards, mechanics, and geologists. Yeah. That's what it takes sometimes. Doing what you gotta do. Alright, now I've got this split off with a Y. And let's see if this works like I think it will. It does work exactly like I think it does. That's awesome, which means the wiring setup inside the case will be very easy. As long as this adhesive material holds, which I don't think it will. is way longer than I thought it would be. That is my bad. Yeah, and that adhesive is very likely not going to stick around for very long. That's okay. I'll 3D print some clips later and make that a little bit more of a permanent installation. But this should be a huge improvement in lighting in this thing. At least once I get it all mounted correctly. Oh, look at that. It's actually blowing out that camera. Boy, that looks a whole lot better. I am totally sticking with that idea. I have a mechanical engineering degree. The other guys are electronics engineers. Yeah, I mean, that training is great. Absolutely. All of my electronics and engineering skills are just hand-learned hobbyist stuff over the years. Honestly, computers and electronics have been my thing. There seems to be a lot of junk in orbit to get as well. Yeah. So the first person to come up with the best solution, the best repeatable, controllable, low-cost solution for collecting some of that shit in orbit, they're going to make a whole lot of fucking money. Just clearing out space for other projects, clearing out debris. I mean, once somebody has a reliable way to do it that they can repeat and do on command, people are definitely going to start spending money on that. Yeah, I know there is no low cost up there. Although there are options for lower cost. There's a guy named Brian Stofield, Stofield Aerospace, who is he's using 3D printing as well to make rockets for low cost, low Earth orbit payloads. And that's the kind of thing he's trying to develop into a real functional, low cost, smaller package project, and things like that. Maybe he can actually, maybe his lower cost platform could be a better launch pad for projects like that, where you're actually, sending out, say, a Teflon collection net to collect pieces of space junk. That kind of stuff would be great for like single-use rockets that are smaller. They're printed either in carbon fiber plastics or metals, lightweight metals, to get those payloads up there easier. He's trying real hard with that project to make money on that. I actually met him at the Midwest Rep Rap Festival back in April. And he was actually printing out the actual bodies for these rockets. I say we send drones to collect it all in one spot and then send it to higher orbit, put a refinery in space. Yeah, unfortunately, a lot of that material though is at different locations and it's running at different speeds. The speeds is a big problem. Some of it's lower and faster, some of it's higher and slower. All right, so let's see. And at the same time, also too, one of the cool things about the projects that SpaceX is doing is SpaceX has, and even some of the other launchers, they have space for smaller add-on payloads for little things like CubeSats or smaller sats that actually could, say every big satellite launch could accommodate 10 smaller CubeSats that are junk cleaners. So every time we launch something, we also launch a bunch of junk cleaners at the same time. And that would be, launching a lot of drones and just piggybacking them on an existing launch. There's tons of good ideas like that. It's just all the details would need to be worked out by the people to do that. Let's see how this thing prints. I'm gonna get a close up of those parts and see how well they look. Oh. Some of these actually look really good. And it looks like most of the junk plastic is gone off the nozzle, thankfully. So it's printing much cleaner now. So it actually might finish these prints pretty well. Too many details in the details, yes. And there's details that you don't know until you do something, and then, of course, you learn after the fact. Let me double check the print status on that one. It's been going for 1 hour and 45. Still says it's got another couple hours to go. That kind of sucks. But hey, I will be up for it. I want to get these parts done. I definitely want to get these parts done and actually have something to show my friend tomorrow when we get into the office. Say, hey, look, here's some sample game pieces. Depending on the settings, depending on the quality that comes out, we can definitely adjust the resolution. You can adjust the resolution to get finer quality parts as far as like surface detail goes. When you have thicker layers that you put down, you lose some of that surface resolution, some of that surface like visual quality. But the actual thicker layers of plastic are stronger versus a bunch of thinner layers. There's a lot more of that material in there to help with the bond, which it seems weird, but people have done quite a few tests. The thicker the layers, the stronger the part tends to be. As long as you're laying down the part with the correct nozzle size and for the height, so that the plastic is actually getting compressed out in a layer. Oh yeah, the resolution on plastic, as far as for the Z height, this part was printed on a printer with an XY gantry on top, or an XY gantry, and then the Z direction actually grows upward. The resolution on the Z on this one, I believe I can get it down to about 50 micron, but usually I print anywhere between 100 and 200 micron depending on the part. I believe this one was 150. Literally, with the modern slicer software that can take objects and prepare them for the printer, you can actually set up multiple resolution during a print, so that some layers that have less detail on them, that would need less resolution, would actually have a thicker layer on them. So you're just printing faster. Instead of printing 2 100 micron layers, you just print 1 200 micron layer, and you save a little time in that. I can take the same object, throw it back into my slicer, and say, hey, I want a resolution of 250 micron, which the layers would go faster since there are fewer layers. Since of course they're thicker, there's fewer layers that have to get put down. And of course, there's a trade-off: the resolution versus the print time, considerations in the plastics. But like changing the plastic, at least in the Z direction, is settings. As far as the XY direction, that's mostly a limitation of mechanics. As far as the positioning goes. But as far as the actual diameter of the plastic goes, literally it's just a tiny little nozzle that I can go in there with 2 wrenches, unscrew that nozzle. Currently I have a 0.35 millimeter nozzle on there. I can just put in a 0.8 millimeter or even a 1.5 millimeter nozzle that will put down more plastic faster for larger objects that might not need smaller resolution. And like changing out, let's see if I can. I don't have my spare hot end handy, but literally changing the nozzles on it is child's play. It takes 30 seconds. So if you took, say, plastic and layered it with carbon fiber, and as you put the layers and use a 3rd layer of metal like aluminum, would that work? The carbon fiber and plastics would work. Carbon fiber and metal would work, but if you try to start mixing metal and plastic, you're going to have severe problems. Most of the plastics we work with have like their top end temperature, they can only go up to 250 C before they start actually burning. Some of them can go as high as like 300, 350 C before they start burning. So mixing just the regular plastics and the metals in a single print is not something we have a solution for. Other than carbon fiber, I guess you could call carbon fiber a metal, maybe. But you don't have to heat up the carbon fiber to lay it down. It literally, you just embed it in the plastic and the plastic surrounds it. It sticks to the plastic. If you use cold metal wire, maybe a really fine, like the stranded aluminum or copper that's in basic wiring, you probably could get that in there as well, but it would have to be cold, or at least cold for a wire. In fact, let me see if I can take a look at that printer. I'll show you a link. One sec. Let's see if I can pull that up. Oh, it looks like Markforged actually does metal 3D printers now. In fact, if you go, I'll paste it here in chat. Markforged.com. They have some pretty good solutions, it looks like. I haven't seen their metal printers yet. I didn't know they had a line for that. But those printers, they actually look relatively small compared to some other machines. And they're showing on they have a printer they call the Metal X, a bracket for an aircraft. Machined cost $1,800, Markforged printed cost $33. Of course, they have a limited build volume on that one, 300 millimeters by 220 millimeters by 180 millimeters. That one, the metal resolution on it is 50 microns, which is actually better than I have settings for this plastic machine. And it looks like their printer, the Metal X printer, is using atomic diffusion additive manufacturing. So that's it's metal powder. It is a metal powder mixed with some type of plastic, so that you can actually, it's actually similar to some of what these printers are, but they print out that metal, the binder plastic holds that metal powder together, and once the part is printed, they take the whole metal part, stick it in a furnace, and burn out the plastic and completely like sinter and fuse the whole part. Which, I mean, that's actually not a bad idea. That's not a bad process. And the machine that does it actually doesn't look. Oh, in fact, they are saying here that their metal printer will print Inconel 625. Oh, that is pretty impressive. Gosh. Of course, and yeah, it does look promising, and on their website there, you know, the Metal X printer by itself standing there looks pretty cool. It doesn't look super huge, you know, a small refrigerator, medium-sized refrigerator. But then, of course, after you get it printed, you have to actually go through and put it in a furnace. And of course, they sell furnaces as well. They have their Sinter 1, Sinter 2 furnaces. And then after the furnace, you actually send it through a washing station to wash any of the plastic residue out. I mean, that is pretty darn cool. Man. Oh yeah, and the machine's not heavy at all. It's a 150-pound machine. Yeah, it is essentially a large refrigerator. Now I need a chemist buddy. Yes. Oh gosh. If you're into plastics and metal chemistry right now, there's a whole lot of money to be made in additive manufacturing. There are materials coming out every day. There are materials actually that I don't have that are kind of expensive, like yeah, I think this half-kilo spool was somewhere around 30 or 40 bucks. There is a spool this size with a half kilo on it that's got a super strong nylon filaments that are hundreds of dollars per spool, just because they're such incredible materials. A little bit out of the reach of the hobbyist. All right, what do I have going? So cool. Definitely thanks for sticking around, Wally. Hope I've kind of piqued your interest, and you can kind of shoot some ideas off of me. I hope you're actually getting some out of it here. So off subject, but do you think we will see transparent aluminum? Yes, actually we have transparent aluminum. Google it. It is currently very limited, very difficult, but we do have transparent aluminum. The current versions of it, I believe, last time I checked, weren't like purely transparent. They were translucent. And the thing about transparent aluminum, I don't know how into geology you are, actual gem materials, but sapphires, rubies are, and a few other gems are actually aluminum. They're aluminum based, and they are transparent. They're very structured, and they have different types of contaminants in them that change the color. Rubies have a red contaminant, sapphires have a blue contaminant, but they are very regular structures of aluminum. And that's one of the reasons why people have been thinking about the idea of a transparent aluminum. They want that ability to make these rubies, but they want to make them clear. And of course, they want to make them large panels. It's still very difficult to make chunks of it. Last I looked, anyways. So there is a lot going on. There are people that really want to dig into it. Oh yeah, okay, so you are getting something. That's good. You're learning a lot and taking notes about 3D printers. Yes, 3D printing. There is so much to learn. I definitely recommend that if you want to learn about the actual process, the 3D printing process, and getting a workflow going, I definitely suggest buying a reliable pre-built printer so that you can understand the process before you start getting into things like building your own custom machines. Because if you try to learn your own custom machines first, it's gonna take you a lot longer, and you're gonna miss out on understanding the entire build process. This machine back here actually is an extremely low cost machine. It was $150. The frame on it is actually 6mm acrylic. It is horrible. Acrylic is not a structural material. But being acrylic is dirt cheap. I mean, you can get a sheet of it and laser cut it for pennies. And then you throw on some metal rods and some 3D printed parts, and it turns into a printer. I would never recommend anybody buy a $150 printer unless you are really looking to see the absolute worst of it. The printer I have in the corner, the Mendel Max 3, currently I think you can get those for around $1,000, but originally it was a $1,500 machine, and I put more money into it for upgrades and the extra things on it. There are machines that are this size here, this big black frame. Raise 3D makes some really good large format machines here, and those are a few $1,000s up to $10,000. Depends on how much space you want, the options for printing multi-materials at the same time. My techies are wanting to buy a kit and build one that way. I am more the gear and engine guy. Yeah, you know, I definitely think your techies should, if they want to do a kit, they should also get one that is not a kit, or they should get one that's a really high quality kit. There are some kits that are absolutely amazing, and they only take a few hours to build. The kit, the Mendel Max 3 that's printing here on camera, that came as a kit, but that took me, like, I wanted to get everything right. I wanted to have everything aligned properly, everything wired properly. And it took me, honestly, 20 hours worth of build time to get everything exactly how I wanted it. This big machine that I've got here is, I think I've got maybe 5 or 6 hours of build time into it. It's not a super high amount. Most of this is just thinking about getting the ideas right, printing out the interface pieces, like these white plastic pieces. Back here hold bearings, linear bearings. And unfortunately, it's stuck to the screws at the moment, so the platform, I can't move it up with my hands, but it does move up and down. If you buy one of the nicer kits, you're going to get some really nice parts, but you will have to understand that when you get the kit together, there is a process of calibration, testing, test prints, temperature testing, and a lot of the pre-built, fully assembled, ready to go kits that you get, or ready to print machines. All of that calibration is done. So literally, you start feeding it material, it starts printing out parts, and those things are fantastic. I'm a tinker guy, so of course the first thing I bought was a kit. And it took me a while to save up for the kit because I don't have a whole lot of money to spend. This $150 plastic machine here was a test build. We built it on stream. There were 5 of us participating, building it all at the same time to kind of get people to understand how you run through a whole build, all the little things you run into, why $150 printers suck so much. GearBest link. Oh gosh, GearBest, really? Okay. That is a CR10 style printer, which does have a lot of similarities to the one I have printing right now as far as the base idea of how the parts move. Unfortunately, like that printer that you see there, that is definitely, that's a lower cost, lower quality kit. You will learn with it. You will be able to print things with it. It's not, like that kit is not hard to put together. Honestly, that or a CR10S or Even something like an Ender 2 or an Ender 3 printer, which I don't know if they've got one on there. Ender 3. The Ender 3 is not bad, and the Ender 3 is a cheap printer, but it's one of the okay cheap 3D printers. Although I can tell you with that printer that they want from GearBest, Chinese printers are made as cheap as possible so they can increase their margins. They are very rarely made with quality in mind. So just keep that in mind. Yeah, you gotta be real careful with Chinese kits. This thing back here is a Chinese kit, and I would not trust this thing to print while I was not at home. These things are known to actually have issues where the wiring comes loose and it shorts and it causes fires and these things burn down. And some people have burned down their houses with them. Honestly, that can happen with any printer. I definitely have some insurance on some of these other printers. There's a lot of metal, very little plastic in these things. And also cork. Cork is amazing. Cork is fantastic. Cork can save your ass. You can buy rolls of cork, and they even thin sheets like this that you can unroll and stick to things. The temperature resistance, it's flame resistant. Literally, you can sit there with a lighter and torch it, and it's lightweight and super heat resistant. So I always have rolls of this that go into critical parts on the printer, just so things don't burn down. And of course, when you print larger prints, like that printer that you showed, the U10, that's a clone of the CR10 style, which is a clone of i3 styles printers. It's just a larger machine. You're definitely going to go through a lot of learning. Your guys are going to go through so much learning. And it's going to be a pain in the ass. But learning's good. When they go through, start building that printer and they start printing in plastics, they're going to learn a lot of the processes, the mechanics, the way things act, the stupid things you will run into. There are so many stupid things you run into with 3D printing. You're like, oh crap, now I just wasted 100 grams of filament. I got to start over again. If I'd have thought of this, I wouldn't have had to ruin my print and start over again. And then sometimes prints will be perfect all the way up until that last minute when they do things like this, where the top of the print fails, things jam. Things you have power outages, and when you have power outages, the machine gets power again. When machines power up, they generally, with a few exceptions, they don't know where they are. They don't know where the mechanics are, the X, Y, Z. They don't know that there's something on the bed. So you can't, if you go to start printing again, or if you want to continue a print after a power loss, you need firmware and hardware built in to the controller so that the controller knows, hey, look, the power just went out. I have a 10-second battery backup that stores all the parameters, and next time I boot up, I'm going to say, oh yeah, I was in the middle of a print. Do you want to continue, yes or no? And you hit yes or no, and it generally will heat things up. And if the break between prints is short enough, you can definitely continue your prints. If you have a print that shuts off and the power's gone for a whole day, the print chamber, the heated bed, all of that stuff cools down, and you're very likely to have the printed part literally pop itself off of the print bed. Because when plastic cools, like any material, it contracts. Plastic contracts quite a bit. And when they contract, of course, the glass bed material that's in there is borosilicate. It doesn't have, the thermal expansion coefficient on that bed is super small. So when it heats up and cools, it doesn't move. Plastic, however, it will shrink. And of course, when it shrinks, it pops itself off. We have a 45K budget for the mining bot build, so if we can do it cheaper through 3D printing, 5K on the machine, worth it in the end, yep. But then again, too, you guys, you have a lot of learning to do and processes to develop. And when you develop the processes the first time around, it's not cheap. It's always once you've refined everything, you've got your subsequent processes down, that's when prices start to come down a little bit. Definitely a lot of work ahead of you guys. Good luck on that. It is getting late, and actually that print's going to run for quite a while. I finished my lighting, so I've got to tack that up. I'll probably actually throw some nails on there to keep the lighting strip up. Yeah, gosh, I've got a whole bunch of stuff going here. But I think I'm done for the night. I've been on for 2.5 hours this time around, and my wife has gone to sleep, so I need to stop making so much noise. If you want to stop by another time, definitely go ahead and subscribe. I try to stream a couple times a week. I also work with other 3D printers, other people that do 3D printing, moderate their streams, participate in their stuff. We do lots of projects, lots of people on Twitter as well. Twitter, YouTube, Twitch, lots of stuff to look at. Just make sure your team understands that any of the stuff that they find on GearBest, Banggood, AliExpress, those things are dirt cheap as far as their construction quality. So be wary. Cool. Thanks for the follow. I appreciate that. I'm on Pacific time, so I normally stream in the evenings on Pacific time or on the weekends as well. Awesome. Hey, and there it goes. It's shows that you're now following. That's pretty cool. That's actually the first time I've had that pop up. I just got that set up recently. So great. Thank you for the follow. When we have more things to post, we'll send you YouTube of the Jeep in action. That would be awesome. I would love to see that. Definitely send me links to that stuff. You can also find me, I probably don't have anything in my description, do I? I need to update my descriptions. I'll post a link. That is my Twitter and YouTube. I don't do a lot of stuff on YouTube. I mostly will post my Twitch videos over to YouTube after they've streamed. That's my username on YouTube. I don't have a link available right at the moment. I need to get all this stuff set up. I'm still pretty new to streaming. As far as streaming my own content, I have moderated for other streamers for quite a while, so I understand how they run their stuff. I'm just still working on getting my stuff set up. And this setup literally has only been in place for less than a week. So great. Thanks Wally for joining. Appreciate it. It's nice to be able to have somebody to talk to about some of their ideas and the projects they're working on. So definitely we'll see you around. It looks like you're the only person left on the stream, so thanks for joining. I'll see you another time.